Okay, this is Chapter 1, Lesson 7. It is called Rate of Change. And we have 3 vocab words to get started with. Our first term is rate of change. And rate of change is a ratio that compares how one quantity changes with another quantity. So we're not just talking about if we have a proportional relationship here. That's not really the point of rate of change. We're seeing if the one unit changes the same way as the other unit changes. So let's talk about, let's say you earn $10 per hour. So for every hour you work, you earn another $10. So we would be talking about how does the money change as the hours change, and do they always change at the same rate? So this is not about being proportional, so put that in your head right now. This has nothing to do with being a proportional relationship. It has everything to do with how the units change together. So the next one is a constant rate of change. And a constant rate of change is a rate of change in which all the unit rates are the same. And what that means is a rate of change where the one unit changes at the same rate as the other unit. So when I talked about earning $10 per hour, every 1 hour that goes by, you earn $10 more. That would be a constant rate of change as long as you continue earning $10 for every hour that passes by. Okay, so it's not like you earn $10 for the first hour and $15 for the second hour or something like that. We'll see more of these and it'll make a little bit more sense as we go. The last word is actually a Greek letter. The Greek letter is called delta. It is a triangle. It's the Greek letter D. It is a math symbol, and this math symbol represents change. And to find change, we are going to use subtraction. Okay, so make sure you link delta with subtraction in your memory. We're going to see delta in Chapter 1, and we're going to see it again in Chapter 2. Okay, so 2 notes. The first note is a rate of change can be found using the formula. Are you ready for this? Delta y over delta x. Okay, so delta y over delta x, that means we're going to be dealing with a table. We're going to have some x values and some y values, and we're going to find the change in our y's and the change in our x's. Okay, so we're going to do a lot of subtracting here. And then we do have to remember always to change this rate into a unit rate. So we'll be using subtraction, and we will be using division to change it into a unit rate. Okay? There we go. All right, so let's do an example problem. I've got 2 practice problems for you. Example number 1, Lori hand weaves custom baskets. She charges a price based on the amount of weaving it takes to make the basket. So if she has to weave 3 inches, it'll cost $15. If she weaves 5 inches, it costs $35. If she weaves 7 inches, it costs $55. If she weaves 9 inches, it costs $75. And the question is asking us to figure out the rate of change. So the first thing we have to do is remember our formula. The rate of change formula is delta y over delta x. And you are going to love this. This is very, very easy. So first we're going to go to our y's because we want to find our delta y. So we have to find the difference from the first y to the next y. Okay, so the difference between 15 and 35 is plus 20. And then we'll find the next delta y, and 35 to 55, that's another difference of plus 20. And 55 to 75, that's another difference of plus 20. So my delta y number is 20, and that 20 goes with the unit of dollars. Okay, so we're writing a rate here. We want to make sure to have units in our rate. Now we have to find our delta x. Delta x is the change in x's. So first, the change between 3 to 5 is plus 2. 3 plus 2 is 5. The next delta x is plus 2. 5 plus 2 is 7. And the next delta x, 7 to 9, is also plus 2. Okay, so my delta x number is 2, and the units that go along with that 2 are inches. Now don't forget, we do have to turn our rate into a unit rate, and I will do that with a little bit of division. I will divide by 2, and I will get $10 per 1 inch. Okay, so this is a constant rate of change because every single one of our delta y's and delta x's equaled out to be the same unit rate. Okay, each of our delta y's were 20, each of our delta x's were 2, so we only had to do the math one time, and we got $10 per 1 inch. So in our explanation, we are going to write an explanation for every single problem, and we're using some good ratio language here, for every, and what we do is we say for every 1 inch, we want to take that bottom unit first, so for every 1 inch, Lori charges $10. And that is the rate of change. So as the basket increases by 1 inch, the price will go up by $10. Okay, as the basket increases by 10 inches, or 1 inch, the price increases by $10. Okay, so this is a constant rate of change because all of these units equaled it out into the same delta y over delta x, same unit rate. Let's check out another one. Example number 2, the table shows the number of students that buses can transport. All right, so remember the formula. The formula is delta y over delta x. Okay, so first we need to find our delta y's, and our first delta y, 140 to 210. If you can't figure out what you have to add to get from 140 to 210, just go ahead and do a subtraction problem. 210 minus 140 is 70. Okay, so we're increasing by 70 here. Let's do that again. 280 minus 210, that's another increase of 70. And 350 minus 280 is another increase of 70. Okay, let's take a look at our rate here. So our delta y number is 70, and our units are students. So 70 students. I'm just going to abbreviate. I'll write it out. So 70 students is our delta y number. Now we need to find our delta x number. 2 to 3, we're increasing by 1. 3 to 4, we're increasing by 1. 4 to 5, we're increasing by, you guessed it, 1. So again, all of our unit rates end up being the same here. And our delta x number is going to be 1. And that 1 unit goes with buses. Okay, so we are lucky here. This is already a unit rate. All we have to do is write our explanation. And our explanation is going to be for every 1 bus, there are 70 students. So as we increase the number of buses by 1, we can increase the number of students by 70. Now you'll take notice to the fact that there is an empty piece of my table here. Again, just really quickly, I want to note this is another constant rate of change because all the units are the same each time. They go up by 70 and up by 1, and they result in the same rate of change. Now, a quick question here is, what if I put the number 8 here? Let me write that in with my marker. 8. Okay, I want to show you how we can use our rate of change to help us solve for a missing value in a table. This will be one of your practice problems. This will also be some bookwork questions. So take notice to the fact that this time we're increasing our x's by 3. So if we increase our buses by 1, we increase our students by 70. If we increase our buses by 3, okay, see how we can use that unit rate to figure this out? 1 bus times 3 is 3 buses. 70 students times 3 is 210 students. So if we increase our buses by 3, then we're going to increase our students by 210. Okay, and 350 plus 210 is 560. Okay, so there will be questions like this guy at the end where you have a table that has a constant rate of change and you have to solve for one of those missing pieces. First, solve for the unit rate and then figure out how big of a jump we're taking here in the delta x's, and use that jump to help you find your jump in the y's as well. Okay, we will see some more examples of that, like I said, in the practice problems and in the bookwork. So, take your notes, update your flashcards for vocab, ask any questions tomorrow in class, and don't forget to finish those practice problems. Have a good day.